further ado, we're going to get into it straight away for tonight's show. And a very big congratulations to Space Store and Nick and Terry, because this is actually our 10th show. So a round of applause for Nick and Terry if you're sitting at home watching. It's going to be another cracker. Do tune in. If you have any questions, do let us know in the comments below, and we'll be sure to get to them at the end of the show. And I'll hand it over to Nick and Terry now. Have a good one.
Cheers. Thanks as ever to our wonderful friends at the Space Store. How you doing, Terry?
I'm fine. Looking forward to this as always.
Good. Yeah, 10 shows. Amazing. We're just saying before we came on air how the year has just flown by. Quite amazing. Anyway, so we got a fun packed show for you tonight, and we got some quite interesting topics we're going to talk about. First one is something that's very dear to my heart, and that's the topic of space junk. It really annoys me. Lots of mega, in inverted commas, mega constellations going up in the sky. China and Russia have both announced that they're going to be putting up vast constellations as well. So this problem that we're about to talk about is going to get a lot more serious. Currently, there are around about 13,000, and you heard me correctly, 13,000 debris avoidance maneuvers per week up in space. That can be automated systems, automated station keeping, as it's known, and that's all well and good. And so far we've been quite lucky. There've been very, very few collisions up there. The most famous probably being the Cosmos Iridium collision back in 2009, which generated several tens of thousands of pieces of debris. Now, the problem with this is that not only that, there's been what they call ASAT tests, anti-satellite missile tests from China, the United States, and quite recently the Indian government basically wanting to demonstrate their prowess in blowing up the satellite in orbit. And that, again, is creating masses of debris, some of it orbiting up to 2,200 kilometers above the Earth. That's way above things like the ISS. Now, the ISS is clearly the largest thing humanity's ever put into space. I mean, this thing is the size of a football pitch. So when some debris is coming its way, you're going to know about it, or you hope you're going to know about it. And this is the thing, NASA and Space Fence and various other systems are tracking as much as possible of this orbiting debris, ranging from around about 5 centimeters upwards is trackable. Below that, it's really, really difficult. But when they do get a heads up that there's going to be a collision, typically what then happens is the ISS crew, maybe they'll get 90 minutes, maybe a bit longer, of a potential collision event, and they'll be told, right, you're going to have to perform a burn maneuver. Now, what a burn maneuver is basically firing the thrusters, and that could be on the Soyuz, which it was in this case, to get them out of the way of the debris. Now, it's not saying they don't get hit, because they have been hit. There's been issues, quite clearly identified with some of the EVAs on the solar panels, where there's been jobbing great big holes torn through the solar panels. This one happened quite recently. This was a quite significant piece of space junk that was heading towards the ISS, and it got to the point where the Soyuz did have to do a burn. Now, in I think 2 or 3 occasions during the ISS's history, the crew have not only had to move into a safe part of the space station, they've had to get into an evacuation state where they're basically inside a Soyuz ready to go back to Earth, much like you see in the movie Gravity when Sandra Bullock finally gets back down to Earth. And I don't want to give any more spoilers away, but she basically gets back down to Earth on a spacecraft. This is the kind of thing that we need to avoid, because whilst I said there's 13,000 of these events at the moment, there's 136 million pieces of debris currently estimated to be in orbit. Now, take that into account. From 1957, when we launched Sputnik, and that one didn't stay up, but lots of stuff since then has. And there was an incident only this week where a satellite that was put up in 1962 was found to still be up there and still quite happily just moseying about. There's stuff up there since the early 60s, like gloves, toolboxes, you name it. Gloves from the Gemini era. You may have seen the famous Gemini spacewalk red, white, where a glove kind of just drifts out of the capsule. This stuff is all still up there. There are 480 million small needles up there, because in the early 60s, America tried to create a fake ionosphere up in space. It's just insane, the amount of junk that's up there. So this is a cautionary tale right now, but one day they're gonna not be so lucky. And the simple fact is that I've been saying this for years now, it's only going to become really relevant to humanity when somebody dies. You only have to look at the space shuttle disasters with Challenger in '86, Columbia in 2003, where the whole shuttle program was cancelled after Columbia in 2003. People start to care when it affects people's lives. And the ISS, there's 6 people typically on board that thing, and that's a $200 billion space station. So you really don't want to A, destroy it, or B, harm anyone. So I don't know, Tev, you've got any additional thoughts on this? Because this really rankles me.
Yeah, the thing is, it's a runaway problem, because every time there's a collision, that sort of doubles, triples, quadruples, whatever, the number of pieces of junk. And as you know, the syndrome is called the Kessler syndrome, where literally things become exponential. And it only takes a tiny piece of debris, about the size of a nail or a screw or something like that, to do serious damage, because they're traveling so very fast. They literally punch right through the outer skin of the space station, and possibly seriously injure somebody inside with those velocities. So it is basically an unbelievable problem, which is only going to get worse. There are various measures in place to try and clean up some of this junk. And just by coincidence, may I mention that our good friend Nick is actually booked to give a lecture to the society that I'm involved in, the Irish Astronomical Association. Just by coincidence, it was booked before this latest bit of news. So that'll be on Wednesday, the 7th of October at 7:30 p.m. It'll be live on YouTube. Just Google Irish Astronomical Association. And the talk is called, with Nick's usual humor, how do you solve a problem like debris? It'll be well worth watching. And this is Nick's tour de force on the subject.
And you can sing along in a Julie Andrews style, should you so wish. It's true, the velocities that Terry's talking about, we're talking about 8 kilometers per second. Now, that is basically the width of London, of central Greater London. So imagining being able to travel across London in 1 second. That's how fast this stuff is moving. At those kind of velocities, any of you remember your A-level and O-level or GCSE physics, KE, kinetic energy, equals half mass times velocity squared. So you can easily work out the amount of kinetic energy that something even relatively smaller, 1 kilogram piece of debris, essentially has the kinetic energy of a small amount of TNT or dynamite, and will just tear through anything. As Terry was saying, something the size of a screw would quite happily go through the cupola, which is the observation kind of module inside the ISS where the astronauts sit and take all the beautiful pictures of the Earth. So you don't want anything large hitting you. There was an experiment at the University of Florida where they fired something the size of a Coke can into a satellite. They were still picking the debris out of the test chamber walls a year later. It generated over 170,000 pieces of debris, and the satellite that they hit was completely vaporized. So you really don't want this to happen. And as Terry said, I'm quite happy to talk until the cows come home about this. To me, it's a really important subject, and it's something that the governments and the defense sector and all of the organizations of the world who are currently just willy-nilly throwing up thousands of satellites with no regard to all this, they're just thinking about their profit margins when it comes to, oh, let's be altruistic and generate internet for everybody. Rubbish. It's all about money. It's all about how much money can they make. And at the moment, nobody seems to care. And somebody will start to care when it all goes really, really wrong. Because when it does go really, really wrong and the Kessler syndrome does happen, nobody will be launching a thing. So that's what's going to happen. Anyway, it just annoys me. Apologies for that. I should become more BBC and impartial. But there you go. It's very difficult with this topic. Brings us on to something a bit happier, a lot happier. So Mars. Terry's going to do a whole kind of thing on this. I'm just going to quickly lead into this with water on Mars. This is, again, a subject that's quite close to my heart because I've been working on a Mars methane sampling mission for quite some time. But Mars, we had all the fantastic story about Venus 2 weeks ago when we did the last show. This is really, really interesting as well. And go, Terry, just tell us all about what's happening on Mars.
Mars, of course, is famed in science fiction as the source of all sorts of alien life of varying degrees of nastiness. But for a long time, we thought that it was very unlikely that there would be any significant life either present, probably very unlikely, or even life in the past, because the surface seemed to be totally dry. Various studies by spacecraft, by telescopes and so on have now indicated that there's certainly liquid water. We knew that the ice caps were there. Originally thought they might be frozen carbon dioxide. We now know there's water. We've seen evidence of flowing water on the surface, even possibly some activity still happening whenever ice just below the surface starts to melt in the Martian summer, but no evidence of any significant amount of liquid water presently existing on the surface until now. And of course, the important thing about water is that we're fairly sure that for any form of life, as we know it, we're going to need liquid water. So basically what happened was that an orbiting spacecraft used an instrument called MARSIS, which is basically a radar instrument, to penetrate under the surface of Mars, and they found what was absolutely certainly liquid water about a mile below the surface around the area of the South Pole of Mars. One moderately big lake, about 12 by 18 miles in diameter, and two smaller ones, each about 6 by 6 miles in diameter. How did they find this? With the radar, which penetrates down that far. It's obviously very specialized equipment. Now, we know roughly the size of the lakes. We don't know how deep they are because the water is actually very, very salty. And that is why the water is actually liquid, even with the very low temperatures that you have at Mars. As you probably know, salt water on the Earth's oceans needs a lot lower temperatures to freeze compared with fresh water without salt in it. So I think this water is very salty. That, by the way, does not mean that there can't be any life in it. So I'll come back to that. But the qualities then of the salt water means that the radar cannot penetrate through that water to see how deep the bed of these lakes might be. So that's just a conjecture. And one could therefore also wonder what exactly might cause a sort of a cavity that would produce any significant depth of water, basically a big underground flat cave, if you like. So that remains to be seen. But the interesting thing is, literally, that we now know for certain that there's liquid water under the surface of Mars. Now, to come back to the life issue, we know that life exists on Earth in the most extreme of conditions, extremely high temperatures, extremely low temperatures, extremely high pressure, radioactivity, high acidity. Can't go into all the details, but if you've ever been to Yellowstone National Park, you'll see bacteria thriving in highly acidic, or indeed sometimes highly alkali bodies of water there. So if life ever gets going, it can adapt to changes in circumstances, like if the water gradually becomes more salty, if the temperature starts to drop. It's obviously not happening very quickly. Life can evolve and adapt to those conditions. Now, the other interesting thing is that we can detect similar things under the Antarctic ice cap. That's one of the studies that was done to show that this sort of technique worked. Under the Antarctic ice cap, it's basically liquid water under the ice. In this case, it's under layers of rock about a mile deep. So it's fascinating. It will be very, very difficult to actually study that because none of the rovers or any sort of spacecraft that we're planning to land on Mars in the future are capable of drilling down a mile to test this water. But the fact that it's there may also possibly be under the North Pole of Mars means that the water's there and there may be other areas where it's closer to the surface and may be possible to detect it. So I would imagine there are quite a few very, very advanced minds in the studies of planetary life and the geology of Mars, looking at how it might be possible to access this water and see if there's any life in it. So Nick, what do you think?
I'm really fascinated by this because, as you said, it's very salty. There's some speculation is it may almost be like a slush rather than a body of liquid water. The issue you've got though is because it's so deep, you've got very increased pressures, and as we know, when you increase the pressure, again that changes the boiling points of water and the melting points and the ice point, etc. Obviously, if you take water up to the top of Mount Everest on Earth, it boils at a lot lower temperature. So if you increase the pressure, you've got a variance that you've got to take into account there. There's also this issue of salt. With life on Earth, they've calculated that potentially life can exist in anywhere between 5 to 10 times the amount of salt that you find in the Earth's oceans. So it does really depend on the whole pressure, temperature, and obviously Mars, there could still be thermal, heating from the core of Mars. It could, obviously it's going to get warmer as you go down deeper. You've got the radiation shielding because you're so far underground. So, and something's creating methane. We know that something is creating methane on Mars. Now, if it's biological processes, we don't know. If it's geological processes, we don't know yet. But hopefully, over the coming years, we will know. The Trace Gas Orbiter is still trying to find out. what's going on. This is Mars Express. Mars Express is the European Space Agency's kind of orbiter that's been there for quite some time. It was part of the mission that put Beagle down onto the surface. Unfortunately, it didn't quite succeed. It got down to the surface, but the solar panels didn't work. But Mars Express has been delivering some amazing science, and it's not quite as kind of sexy, maybe, as the HiRISE mission and HiRISE camera, which is delivering some stunning images from orbit. But it's one of those missions that when I was at ESA, I got quite heavily involved in the science communication side of Mars Express, and it really is a fascinating mission. So one definitely to watch out for, I would say, in the coming weeks and months. And, you know, when the rovers get there early next year, who knows what they're going to find.
There's one other example on Earth which is worth considering. That's the Dead Sea, which is highly toxic for various reasons, but there are bacteria living there, even in the sort of environment that you can bathe in it, but you do not want to get even one drop of that water into a cup, let alone into your mouth.
No, exactly. It's the salt content in the Dead Sea is astonishing, isn't it? You can literally float without even thinking about it. Yeah. So that's Mars. We're now going to go way, 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 way further out. I love this galaxy. M87, it's one of those things in the kind of spring, early summer months, as part of Markarian's chain. There's this amazing string of galaxies. And one of them is Messier 87, discovered by Charles Messier during his surveys in the late 1700s, early 1800s, his 87th galaxy. And even with a relatively small telescope with a camera attached to it, you can see this jet coming out of it. So this superluminal kind of spike sticking out the side of M87. Now, what happened was a few years ago, if any of you listening may have seen a movie called Interstellar. Now, Interstellar was science fiction, but they depicted black holes in a way that had never really been seen before. You know, those of us who grew up in the 70s, 60s, you'll have remembered movies like Disney's The Black Hole in the late 1970s, which showed it as this kind of rotating galactic style disk, and anything that crossed the event horizon got sucked into it and everything died and yada, yada, yada. And that was always the kind of image of what a black hole would look like. Data then provided by a lot of the scientific telescopes was handed over to the team, and this was being advised by a guy called Kip Thorne, who's one of the world's leading astrophysicists. And the data that they were kind of picking up on these black holes was handed over to the special effects team working on Interstellar, and they said, okay, well, here's the raw data, show us what you can make and show us what you've kind of come up with. And they came up with something that looked unlike any black hole anyone had ever seen before. And the scientists at the time were going, that's not what a black hole looks like. Black holes look. Now they've proved that it is. And the special effects team, and I've met some of the special effects team when I was in Switzerland last year, and they just said it was amazing watching the scientists almost with tears in their eyes looking at this data and going, we're actually seeing this. And as Terry's about to tell you, this black hole is quite amazing in what they're getting now from it.
Yeah, as you say, it's one of my favorite galaxies too. It's probably the easiest galaxy to see outside our own local group, which is basically our own Milky Way galaxy and the Andromeda galaxy and the Triangulum galaxy and the Magellanic Clouds. It's 55 million light years away. You can see it with a pair of binoculars because it's huge. It's what's called a giant elliptical galaxy, many times bigger than our Milky Way in the constellation of Virgo. You can Google it or use any way of locating where it is, and even a pair of binoculars will show it. First image of a black hole was taken last year, and that was pretty remarkable. Now, you don't see the black hole itself. You basically see the accretion disk of the material that is falling into it being ionized, turned into plasma. Extremely energetic particles are emitted, and that's what you see. You don't see the black hole itself. We also noticed that this accretion disk around it, this bright disk, was not absolutely perfectly symmetrical. There's a sort of a crescent shape in it, as you can see in that image there. And that's to do with the way the orientation of the way we're looking at it and other things which I'm not going to go into. But when they imaged it again with the Event Horizon Telescope, which is basically a network of giant telescopes around the Earth, they were able to see that the orientation of that crescent, the bright crescent, had changed in roughly 10 years. And that means that it's wobbling. Now, we don't know whether the black hole itself is wobbling or not, but certainly the visible part of the accretion disk is wobbling. And that will tell us quite a lot whenever there's more observations over the years of just how an accretion disk interacts with a black hole. And this is cutting edge science. Black holes were predicted by Einstein. For a long time, people thought they were just sort of theoretical constructs. We now know of lots of them. I couldn't tell you how many, hundreds at least. Certainly there's one in the center of almost all the galaxies that we have studied, apart from maybe some smaller regular galaxies. There's one in the middle of our own Milky Way. So they're fascinating objects. This one has a mass of, wait for it, 6.5 billion suns in one object. And that's almost incomprehensible. So these things are fascinating. They're at the cutting edge of science. They're at the limits of what relativity is predicting. You know, how big can they get? What happens to them? Do they form wormholes to take you elsewhere in the universe? Fascinating stuff. But the fact that this thing is having a bit of a wobble, and we can detect it over a period of 10 years at a distance of 55 million light years, is just mind-boggling.
It really is. And if you go on Nature's website, I mean, Nature have published this, you look at the animation that the scientists have created, and it almost looks like it's rotating. And that could be another, it may not be a wobble. It may be that this accretion disk, that the energetic material is essentially rotating in a style not too dissimilar to the old movies in the way that they depicted black holes. I find them absolutely fascinating when you think that the sun, for example, our sun, which would swallow up the Earth 1,000,000 times, if it was to collapse into a black hole, and it's not going to because it's the wrong size, but if it were to, you'd be ended up with something roughly about the size of a small city. From something that's 1,000,000 times bigger than the Earth. It's quite amazing. If the Earth was to collapse into a black hole, it'd be about the size of a basketball. So it kind of gives you an idea of the level of kind of space that there is in between the atoms and obviously all of the subatomic particles that are orbiting our kind of nucleuses that make up us. So we're basically just a lot of empty space. And it's really, really fascinating. It's one of those things, if you haven't had a chance to see M87 this year, get yourself a little telescope or a good set of binoculars, you know, on a stand or a tripod or image stabilized. Roundabout, as I said, from March, April kind of time, it's really, really a nice, great big chain of galaxies to see with a small telescope. I've imaged this jet with a 3.5-inch Maxitov in the past. It's perfectly doable. So it's a wonderful, wonderful and very interesting galaxy.
Yeah, it's the biggest one in what we call the Virgo cluster of galaxies. And if you have a reasonable telescope, you can actually see a dozen or score of galaxies in that group.
Yep. Absolutely. Moving on to our next story. And just before I do that, actually, we were talking about Mars earlier, and the Space Store, who hosts this, really, really great team at the Space Store. I've been down there and I've given talks at the Space Store in the past. They have a fantastic VR experience. Kind of lasts for about an hour. One of the things that they do in this VR experience, and it really ties into our Mars story that we were talking about earlier, is a cave dive on Mars. Now, this is, it's bizarre who hosts this as well, because it's James Bond's stunt double from the Bond movies. Absolutely fantastic, really, really interesting. My company do a lot of VR work, and I love what the Space Store are doing. So, and it's not just that, there's a whole kind of wealth of experience in there. Kind of, they call it blast off, and it's really, really fun. So if post-pandemic, or if you want to go in now, I'm pretty sure, you know, they're more than happy to host people right now. Pop along to the Space Store. They're based in Didcot, right near the Harwell Space Centre, where my company has got an office. Go along and have a play with our VR experience, and take your kids, because it's one of those amazing things that if you've never experienced VR in a way like this, it can be quite disturbing and fun, and a really good thing to do in these difficult times, especially when you can't go traveling to these real places. So pop along and give that a go. Anyway, moving on. Our next story, Rosetta. I love this comet. So I was involved in some of the ground support imaging for this. Went over to the European Space Agency, met up with Matt Taylor in the early days when Matt had just been appointed as a PI on this mission, a principal investigator on this mission. Rosetta, Comet 67P, Churyumov-Gerasimenko, or Cherry Jerry as we called it, was a really interesting comet. It wasn't the initial target of the mission. That all got changed, obviously, with delays in the launch and what have you. So they basically then decided they were going to visit this comet. Now, I was imaging in it when it was out near the orbit of Neptune. It was a tiny little dot, and we were trying to get a handle on you know, basically the orbital characteristics and continually monitoring it from the ground. Then the spacecraft took over, and the sheer level of data coming out of that was incredible. My only regret, and I've said this many times publicly, is that the European Space Agency spent too much time holding on to that data. They could have had an even bigger coup than they had. It's generally regarded as ESA's Apollo moment in terms of the level of orbital dynamics expertise that went into the Rosetta spacecraft to orbit around the comet is incredible in its own right. The Philae lander didn't quite succeed in all of its aims, but it got down onto the surface. They got some surface images. It then decided to go for a little hop around the surface and bounce around. It took them months to find it again because it kind of descended into this nook and cranny on the comet that kind of hid it quite well. But the science that came out of it, and I know a lot of the team who worked on the science with Rosetta was quite remarkable in terms of understanding how the jetting forms, the rotation rate, what materials are on the surface, and potentially, analysing the water from comets produce the water on Earth. There are all sorts of studies that said yes for this and no for that, and there's still a heated debate over that. This I find really fascinating, though, in that now, all these years later, they're still delivering amazing science. And what they found is an aurora on a comet. Terry, what do you think about this one?
Yeah, that's amazing. You're talking there about the data that came back from Rosetta, but for the general public, even the images that came back were absolutely mind-blowing, unbelievable detail. And of course, it was nicknamed the Rubber Duck Comet, as you can see from that image there. If you turned it through 90 degrees, it's just like the shape of a rubber duck that Nick would have in his bath. I'm much more more mature than that. Anyway, yes, aurorae are familiar to us here on the Earth, caused by solar charged particles interacting with the magnetic field, which channels them down basically towards the north and south magnetic poles, and there they interact with gases in our atmosphere, ionize them, and produce beautiful, beautiful images. We know there are aurorae on other planets in the solar system, particularly on Jupiter and so on. This was the first time that we had detected one on a comet. Now, a comet is basically a big, dirty, gigantic, icy snowball. Different definitions of it, but it's a mixture of ices and dusty particles and gas. And what happens is that as the comet comes in closer to the sun, it gets heated up, and that stuff starts to be given off by the comet. It sublimes, basically goes directly from ice into gas. It doesn't go through the liquid phase first, and that is given off, and you can see that there in the image. So what they've discovered is that the solar charged particles, basically electrons, are interacting with that gas and producing an aurora on something as small as a comet. This thing's only a matter of kilometers in diameter, nowhere near the size of the Earth, let alone Jupiter. Now, unfortunately, for anybody observing it from Earth, you wouldn't have seen that because it's in the ultraviolet, not invisible light. That's due just to the different characteristics on the gas of the comet compared with Earth, although basically very similar, a mixture mainly of hydrogen, nitrogen, and oxygen. So even though that was quite some time ago, and as Nick said, there was quite a delay in releasing the data, they're coming up with these amazing discoveries even now. So aurorae are visible even on a comet out in the cold depths of the solar system.
It's amazing as well. This was suspected on Comet Hyakutake as well, in 1990 C Hyakutake 1996 B2. So I've got a real passion for comets. That's another thing. But it's one of those things that the universe keeps throwing up all these surprises constantly, and it's as we're still learning geological data from the Apollo moon rocks some 50 years later, you can imagine. And the team on Rosetta said this is going to give us a lifetime of science. And it's true. And hopefully, if we return back to the European Space Agency, to my mind, its greatest achievement was still the Huygens lander on Titan. But this one as well, it's got to rank up there in probably the top 10 space missions of all time in terms of, as I said, the orbital dynamics that they performed, quite miraculous orbital dynamics, and the science that's come out of it is quite amazing. So definitely one to you won't be able to keep an eye on Rosetta. or because it's now dead on the surface of the comet itself, they put it down, or the comet, and it's not going to come back for quite some time. So, but it's one of those things that if you see a comet up in the sky, just remember what's going on there. The potential that life was brought to the Earth from comets. We don't know. We don't know how life started on Earth. The potential that water, the liquid water that we rely on for life, full stop, on this planet, could have been brought by comets and or asteroids. We don't know, but it's really, really fascinating. It's one of the most beautiful things in the night sky to look at. We were quite lucky earlier this year to have quite a good comet, so keep an eye out, and hopefully we'll get some more in the coming years. Just want to touch on that VR thing as well. You can book that actually online on spaceor.co experiences. And the guy, the James Bond guy, I didn't remember his name before, it's Andy Torbett. If you Google him, you'll see that he is James Bond's stunt double. It's really, really fun. Now, from comets to asteroids, this is a cracker. So I've got some good friends, John McLean, who works at Exeter at the Moseley Observatory, is one of the NASA ambassadors for this mission. This is a cracking mission. So OSIRIS-REx, this is a really audacious mission. So the Japanese have already done some sample return missions from the surface of asteroids. OSIRIS-REx is aiming to bring back quite a significant amount of this. We'll talk a lot more about this probably in the next show, but I don't know if you had any anything that you wanted to highlight on this, Terry?
What strikes me first is looking at that image and looking at the images that I referred to earlier that came back from 67P, how similar they are. We used to think that comets and asteroids were totally different classes of objects. Now there's a huge degree of similarity. If I had looked at that without a caption, it would have been very difficult to tell whether that was actually Comet 67P or the asteroid. But yeah, this is a pretty small asteroid, only about 0.5 kilometer in diameter. The probe is due to go down very, very slowly into a crater, into a relatively boulder-free area, which is only about the size of half a tennis court. So and remember, this is happening 200 million miles away, so everything has to be done automatically. You can't send a signal to steer the spacecraft down from Earth. It has to be done autonomously, basically. Go down very gently, a probe will touch the surface, then there'll be a blast of nitrogen gas which will stir up some of the dust and small particles, which will be grabbed by the probe, and then the spacecraft will back slowly away. They'll analyze the sample that they've got. They hope to get up to about 2 ounces, 60 grams roughly. If that's satisfactory, that's fine. If not, they have a chance to then go for another sample site and try again, and they can try up to 3 times altogether, and then they'll bring the sample back to Earth, and we'll go into more detail about that the next time. The touchdown's due to be on October 20, so we're planning to have another of these webinars before then, and we'll probably go into a bit more detail about that now. But as you say, a really, really audacious mission to try and do that so far away from Earth.
It's also amazing talking about the orbital dynamics again. If you think orbiting a comet is difficult, and it is difficult because obviously you've got jetting, you've got all sorts of things that the cometry, the analysis team and the science data team and the flight dynamics team on Rosetta just weren't expecting, and they had to back away, and when it was becoming a bit more kind of jetty, for want of a better term. With this, not so much of a problem in that respect, but extremely difficult to get something into orbit around something quite that small. And then, as Terry said, you get a very slow approach, a touchdown, and you've got virtually no gravity on the surface of this thing. You know, you could bounce off it in easily, just literally step off it. It's so small, and the gravitational field is so weak. So it's a case of touching down and not disturbing the regolith too much. And if you go back to the Apollo days, you know, that stuff is nasty. So regolith on the surface of the moon is horrendous. It sticks to everything, and it's very, very corrosive. So they've got to do a really, really precise job here in a very small area, and they've marked out the area that they're thinking of doing the touchdown on. They'll get 60 grams now. 60 grams, it's not a lot. You know, they brought back over 400 kilograms of moon rock from Apollo. So again, that kind of points to, yes, robots are fantastic and they can do great science, but if you want to get a big return on your investment, a big return for science, send humans. But sending humans for an asteroid, that whole project was cancelled, thankfully, and we're going back to the moon and onto Mars now. But it's going to be one to watch, and Dante Loretta and the science team who are involved in this at NASA, all the best from everyone here, because this is a really, really interesting, fascinating mission, and we're going to talk a lot more about that probably in the next show. So that kind of leads us up to big one, World Space Week. And that looks like the Veil Nebula in the background. I've just seen this image. It looks like the Veil Nebula in Narrowband. It probably isn't, but there we go. World Space Week is coming up. So this, we touched on a little bit last time, is a week-long series of events. If you've got an event that you're thinking of hosting, either virtually or in real life, most of the events this year are virtual, but if you've got a telescope, you can connect up to a camera in your observatory and you want to do live streaming, get it registered on the World Space Week website. As Terry found this week, it's not an easy process because they're time stamping in their clock. Am I right, Terry?
Absolutely. It took me about 20 minutes to get something on.
But it's a really great, this year's going to be a bit more muted, probably a lot more online, but the good thing about online events is that you can go anywhere in the world. The thing with World Space Week events in the past is when they've been in local countries, they tended to be like face-to-face real-life events. So maybe observe the sky nights, you'd have people with telescopes in the park, that type of thing. With World Space Week this week, there's hundreds and hundreds of events all over the world. I mean, Terry's just registered the IAA talk that I'm giving in Ireland. I know I'm involved in at least 3 events in the UK during World Space Week. There's dark skies events, all sorts of things happening. The BBC are getting involved as well, some of the Sky at Night team. So it's well worth looking for what you fancy, because this is the beauty of online. You can be anywhere in the world and you can latch into a whole range of different events of real interest. So it's a great way to get people involved in science. And I know everyone's getting a bit probably tired of sitting in front of Zoom presentations and talks, but I'm hoping that some of the talks and some of the presentations for this World Space Week are going to be real crackers. So I don't know if you've got anything to add to that, Terry.
Yep. The theme this year is satellites, which is why your talk fits in so nicely into that theme. And everybody has heard of the International Space Station, and just by coincidence is during a nice series of evening passes at the moment. So you don't actually need to wait to World Space Week start until the 4th of October. There are various websites. Heavens Above is probably one of the best ones for sort of the amateur to have a look at without it being too complicated. It will tell you where and when the space station will be visible for any location on Earth, and it is doing a series of evening passes at the moment. At its best, it can be even brighter than Mars. And Mars, as we were talking about earlier, is coming up just to its very closest on the Earth. It'll be at its brightest on the 6th of October. The third brightest object in the night sky after the Moon and Venus. Venus is only visible in the early mornings just before dawn. So Mars is absolutely spectacular in the evening sky at the moment, rising in the east, high up in the south, just after local midnight. And you might be lucky and see the International Space Station pass very close to Mars, and you can compare the whitish color of the space station, because it's reflecting sunlight, with the beautiful, spectacular reddish glow of Mars. Mars won't be this bright again until 2035. So the next couple of weeks, that's your chance to see Mars at its best.
Sorry, I was on mute then. Just saying about
I was wondering what was happening.
International Space Station. Sorry,
Yes.
I'd muted myself. International Space Station, as Terry was saying, fantastic thing to see, and it's traveling at 17,500 miles an hour around the Earth. Now that's wonderful. Mars, obviously, millions of times further away than that. But when they do intersect each other, and there was an incredible image that I saw in the last few weeks that somebody had taken where the ISS and Mars were in the same frame, and they were using a very high-speed camera connected to a telescope, and you can see this. You can see detail on the surface of Mars and detail on the space station in the same image. So there's your challenge, anyone out there. If you want to try and do that in the next couple of weeks, go for it. there's easier ways to do it. You can just get an SLR and take a picture of Mars, and you'll see a white dot or a reddish dot and see the ISS streak across. But it's one of those things. It's really, really fantastic. As Terry said, Mars right now is spectacular. Some of the images coming from amateur telescopes showing the volcanic regions, the volcanoes on the surface of another planet that is millions and millions of miles away from your back garden. So get out and have a look, and that's one of the great things to look out for in the next coming few weeks.
Yep. There is actually a website, I forget the name of it, but you could Google for it, which will literally give you a detailed calculation of when the ISS will pass across the sun or the moon or very, very close to any of the planets. Anybody that's really, really interested will be able to find that website, and it gives you a calculation down to an accuracy of a matter of meters. So,
well, the Celeste track, or if you've got one of these little mobile phone, doesn't have to be fancy. It can be an iPhone or an Android. You can download a whole ton of apps that will show you where the ISS is, and you can even hold them up to the sky and get what's called an augmented reality view, where you can see the stars and the constellations in the background, and you can see when the ISS is going to pass over. There's also a really fun thing, and I've got one just here actually, as we lead out. This is a Raspberry Pi computer. Basically, I've been modifying and playing around developing a satellite on it. But essentially with Raspberry Pi, you can build an ISS predictor. Some great instructions online for that. And you can basically, using the little displays that you can add to those Raspberry Pis, you can see when the ISS is passing over, and you get it to flash and set off alarms for you. So, and again, you can get an alarm on your mobile phone to say, right, the ISS is going to be in your neck of the woods in the next few days, or the next few minutes, or the next few hours. So all well and good. Enjoy seeing the ISS. It may not be up there forever if our first story comes true and it gets hit by a large piece of debris. On that note, have you anything to add, Terry?
No, just I've seen it so many times I couldn't count, but basically it is still just an amazing sight to see that flying across the size of a football field, as you say, traveling at 17,500 miles an hour with up to 6 people in it, male and female. When I first see it here from near Belfast, it's off the southwest coast of Ireland. And if I get a sort of a complete view, see most of the path before it travels into the Earth's shadow, it is within a matter of minutes traveled from there to being somewhere off the south coast of England in a matter of minutes. It's just absolutely amazing.
I'd love to do that, but last time I was in Belfast and visited Harland and Wolff, obviously the iconic building site for the Titanic, and it must be amazing to see the giant Goliath cranes and seeing the ISS fly over and think that just over 100 years ago, another engineering marvel that the whole world was so proud of was that, and unfortunately that had a little accident. So could be one to bear note of with the ISS.
I hope that's not predicted.
Hopefully not. Coming up, so we got another show coming up in 2 weeks' time. On the 13th, and the Space Tour also hosting a wonderful lady, Libby Jackson. So she does she's part of the UK Space Agency, does a lot of public outreach, really fantastic. She's got a new book out, Space Explorers, definitely worth getting for your kids in particular. She is a really eloquent speaker. So that'll be this Thursday on the Space Tour's YouTube channel, so definitely tune in for that one. In terms of other stuff coming up, next show we're going to be talking about OSIRIS-REx and World Space Week and what happened, etc. All that type of thing would be fantastic. Oh, Space Tour also doing a promotion there, so you can have a look at that. It's fantastic. It's now on your screen. In terms of what else is coming up, there's a really important test launch coming up. So the next Starship, SN8 and SN9 are coming up. And this is when it actually starts to look like a rocket and not a grain silo. So probably in the next show, we're going to be covering that as well. But on that note, thank you very much again to the Space Tour for hosting us. We've run for nearly 45 minutes tonight. So thanks very much to the team behind the scenes to keeping this going. Thank you for reminding me that I put my microphone on mute. Have a great few weeks. And I'll say good night from me.
Good night, and keep looking up.
Once again, thank you so much for another incredible roundup, Nick and Terry. Just a reminder that once again for Libby's talk on this Thursday, make sure you guys register for the Zoom, because we're actually going to be giving away a couple of signed copies of Libby Jackson's latest book, Space Explorer. So make sure you sign up for that and tune in on Thursday at 5:30. And as Nick and Terry have been discussing, Space Week is upon us next week, and Space Tour is actually doing 10% off everything in-store and online. You've got the code on your screen there to use on our website for some amazing merchandise. So head there straight after this talk and see what you can get. And once again, thank you, Nick and Terry. We'll see you guys.
Bye.
Cheers, guys. Take it easy.
Nice. Remember, you can catch up on our YouTube channel if you've missed any of our previous talks. Until then, have a good one.
Adios, amigos.
Bye.